tutorial.net's course on SolidWorks 2009. In this course, we'll be covering what's new in SolidWorks 2009. If you're currently working in SolidWorks 2008, just from a brief review of my interface, you may have noticed that the interface of SolidWorks 2009 looks virtually identical to the 2008 interface. If you're migrating from SolidWorks 2007 or earlier versions, SolidWorks 2005 or 2006, please review our previous chapters about what's new in SolidWorks 2008. Basically, SolidWorks 2009 isn't a major revision of the software as was the release of SolidWorks 2008. A good place to start is to review the product name changes in SolidWorks 2009. The column I've got on the right shows the new name used in 2009. The column on the left shows the nomenclature from previous editions. It's a good idea to familiarize yourself with these new names. SolidWorks Standard, Professional, and Premium are the standard hierarchy of mechanical design products. SolidWorks Premium comes with design validation capabilities as well as data management capabilities. Some of the design validation modules include tolerance stack-up validation, assembly simulation, fully integrated mechanisms, etc. SolidWorks Professional comes with the data management capabilities but not the design validation modules. The Enterprise PDM and the Workgroup PDM packages include more data management tools like scalability, custom configuration, finding and reusing design data, etc., with the Enterprise package giving you a few extra features like distributed design teams, remote access, automated approval process, and an audit trail. SolidWorks Simulation, Professional, and Premium give you a bunch of different analysis products that aren't included in the previous packages I just discussed, like mechanism simulation, product failure prediction, a simulacrum of buckling and collapses, heating and cooling, etc. Some of the other modules that SolidWorks offers are pretty cool as well. For example, SolidWorks Flow Simulation gives you a fluid flow simulation, where you can study the flow of liquids inside your design, including non-Newtonian liquids like toothpaste and blood. And this concludes our Introduction to Video Tutorials course on what's new in SolidWorks 2009. We hope that you enjoy this course and we look forward to helping you with your studies. Welcome to our tutorial about converting files into SolidWorks 2009 files. Let's begin by selecting File and Open from the main menu. Navigate to the file you want to convert and select it. On the right-hand side of the dialog window is a preview thumbnail. Let's click Open. When you open a file for the first time from a previous version of SolidWorks, it might take a little longer than you're used to. It depends upon the complexity of the file. Okay, here it is opened with a pop-up help bubble. The file will be converted when saved. Let's click the exclamation icon. A pop-up window opens letting us know which files will be converted to the current version. We click Yes to convert all of these, and SolidWorks processes our request. Now keep in mind that after you save your files as SolidWorks 2009 files, you won't be able to open them in older versions of SolidWorks. In order to convert multiple files, we can use the SolidWorks Task Scheduler. Let's click Start on the Windows taskbar and then Programs. Select SolidWorks 2009, SolidWorks Tools, and navigate to our Task Scheduler. Let's click on Convert Files. Here we can rename the task type. We can choose to add files or add folders. Let's click on Add File. From the Files of Type menu, choose Parts. Let's Shift select all the parts and then click Open. Now let's click Finish. SolidWorks processes our request. We see the progress here. Let's refresh again. And again. After the job is completed, the status column displays Completed. This concludes our tutorial about converting files to the SolidWorks 2009 format. Welcome to our tutorial about SolidWorks 2009's GUI. we're going to be looking at the enhancements in the 2009 graphic user interface. We've got the ability to undock the property manager and position it in a different part of our screen. This rectangle indicates the place where the property manager can be positioned. The same is true for the command manager as well. When I mouse over the square, I see a blue dark area that lets me know where the command manager can be positioned. We can also position the command manager outside the graphic area. You can also position the command manager on a second monitor if you're running 2 or more monitors, and this makes the use of the graphic area real estate a lot more efficient. This concludes our tutorial about SolidWorks 2009 Graphic User Interface Enhancements. Welcome to our tutorial about SolidWorks 2009's Magnifying Glass. The Magnifying Glass feature helps us make selections without changing the overall view. To activate the Magnifying Glass, just place the mouse over the area you want to view and click G on your keyboard. If you get a warning message, and just hold on, I'll explain in a little bit how to deal with this problem. Now, if I move my mouse, the magnifying glass moves along with my movements. If I hold down Control and then press the middle button, like for example your scroll wheel, now we see the panning tool. I can place the magnifying glass on the area I want to zoom. Now when I scroll the mouse wheel, I can zoom an area in and zoom it out. If I hold down the Alt key, I can preview the section view parallel to the screen. We can still move the mouse. If I press Control and then make a selection, after I make my selection, the magnifying glass is still open. Let's try that out here. If I make a selection without holding the Control key, then the magnifying glass will close. I'm going to press G. In order to close the magnifying glass, you can press G or simply press the Escape key. Now, if you receive a warning message when you try to activate the magnifying glass, go to Options, Performance, and here, Grayed Out, is the option to use Software OpenGL. You might be wondering why it's grayed out. Well, there's a reason for this. Let's cancel out of here for now. I need to close my assembly first. Now, when I go to Options and Performance, the option to use Software OpenGL is available. I'm going to leave it unchecked and cancel out of this window. Okay, let's go to File and open our assembly. Give SolidWorks a minute to process that. The next place to check is Hardware Acceleration. Right-click on the desktop and select Properties, Settings, select your monitor, and click Advanced. Go to the Troubleshoot tab. You may need to adjust the hardware acceleration with this slider to make sure you've got maximum acceleration. Let's cancel out of this. Finally, let's go to SolidWorks website. We go to Training and Support, Technical Support, go to System Requirements and Graphic Cards. Let's scroll down a little bit. Here you can choose your graphics card vendor. Let's say NVIDIA. Select the software version. and then select your operating system. You can choose a tested card, or you can show all the cards. Here we can scroll down and view all the details for all the cards that have been tested by SolidWorks. Lastly here, in order to assign different shortcuts, we can go to Tools, Customize, Keyboard, and in the search field, let's type Mag. We pull up the magnifying glass. Here's our shortcut, G. I'm going to cancel out of this right now. This concludes our tutorial about the magnifying glass. Welcome to our tutorial about appearances in SolidWorks 2009. In this version, colors and texture are now included under appearances. As a result, the visual attributes of the model are presented consistently in different modes. Even if the real view is off or on or rendered in PhotoWorks. It's a cosmetic enhancement, but it does improve the seamlessness of the interface. The new icon family here indicates that appearance and scenes are no longer dependent upon the real view. SolidWorks 2009 has a new tool. It's called Edit Sketch or Curve Color. Right-click anywhere on the menu and select Customize. Commands. Now let's scroll down and select View. And let's drag on the Edit Sketch and Curve Color command onto our command manager. Click OK. Now let's expand the top housing. Surface Extrude 1. Make the sketch visible. The sketch is right here. Let's activate the new tool. Select the sketch and let's convert to red, for example. Click OK. Next, I'm going to modify the appearance of the top housing. Let's right-click, Appearance, drop-down menu. Here we can select Face, Body, Features, or parts that we want to affect. Let's make some changes in the Appearance Property Manager too. When you select an item, you'll notice its preview thumbnail on the right. Open and click OK. And this concludes our tutorial about what's new with appearances in SolidWorks 2009. Welcome to our tutorial about the Move, Copy, and Rotate Entities tools in 3D Sketch. Let's start by creating a 3D sketch. We'll select the Line tool. And let's create a line starting from the origin point along the X-axis. Click the Tab key to change planes. Now let's create a second line along the Z-axis. Click the Tab key again. Let's create our last line somewhere here. Okay, right-click, select. Now let's activate the Move Entities tool. Under Entities to Move, I'll select this line. Here we can simply grab by the arrow and then drag it out in the desired direction. The corresponding delta values appear in these fields here. We've also got the option to select a translation reference. I'm going to select this line. I can change the numeric value in the distance field here. Here's a preview of the position of our entity represented by the shaded line here. And let's cancel out of this. The second tool is Copy Entities. Let's select the same line. Once again, we can drag the entity into the desired position. Or we can select Translation Reference and enter a numeric value. Let's OK that modification. And here is our second line. Let's take a look at the last tool, Rotate Entities. I'll select the same line again. Here we've got the option to enter the rotation origin and the rotation angle. We can adjust with these arrows, or we can select a rotation reference. And let's click OK. And we're ready to exit our sketch. This concludes our tutorial about the Move, Copy, and Rotate Entities tools in 3D Sketch. Welcome to our tutorial about equation-driven curves. Let's begin with a right-click, Insert Plane. Now let's insert a sketch. Next, let's go to Tools, Sketch Entities, Equation-Driven Curves. Here we can specify the equation that defines a curve. Equation-defining curves are specified as y as a function of x. For example, x plus 3. If the specified equation can't be resolved, the equation color will turn red. x1 and x2 are the starting and ending points, respectively. If I enter 0 in x1, this effectively starts the curve at the origin point. And for my endpoint, I'll use 5 pi. We also have the option to fix the start and end point of our curve by clicking on the lock icon that you see here. Let's zoom in a little now. I've unselected the lock icon for the start and end of the curves at this point. Let's click OK. As you can see, I'm able to grab, for example, the end point and move it. Same is true for the start point. To go back to the Equation Curve Manager, simply double-click on the curve. Now let's lock the beginning and the end of the curve in place. Click OK. As you can see, I'm unable to change the position of the start point and the end point. As you can imagine, this is a very handy feature. Okay, we're ready to exit our sketch. And this concludes our tutorial about equation-driven curves. Welcome to our tutorial about numeric sketch input. First, let's enable the numeric sketch input option. Select Options, Sketch. Now check Enable on-screen numeric input on entity creation. Click OK. Let's right-click now and insert sketch. We'll select the circle tool. Next, I'll click and release the mouse. And numeric fields are ready to accept a value, as you can see here. I'm going to type 50 and press Enter. Next, let's create a rectangle. Click on the origin point and then release the mouse. As you see, one of the fields is ready to accept input at this time. This time, let's enter a negative number, minus 70, let's say. And tab. Let's enter 60 here. Now click Enter. What I wanted to point out here is this. You're now able to enter a negative numeric value. Let's click Enter and exit our sketch. And this concludes our tutorial about numeric sketch input. Welcome to our tutorial about the Repair Sketch tool. It's been enhanced in SolidWorks 2009, and that's what I'm going to cover briefly in this tutorial. It now locates more types of errors and errors in sketch elements and lets you repair some of these interactively. Let's click Repair Sketch. You see no problems found. Now let's request the tool to show gaps smaller than 0.5 millimeters. Click Repair. The magnifying glass lets us view the problems. Here we have a second problem. In this case, we can simply drag the points and merge them together. And this concludes our tutorial about the Repair Sketch tool. Welcome to our tutorial about slot entities. In SolidWorks 2009, you're able to insert slots in sketches and drawings. Let me take a moment to show you how this is done. Let's begin with a right-click on the front plane. Insert Sketch. We've got 4 types of slots to review: straight slot, center point straight slot, 3-point arc slot, and a center point arc slot. Let's begin with the straight slot. You can see on the thumbnails here the first point, the second point, and the third point. I'll insert the first point. Second point, I'm going to specify the length of the slot. Here we can specify the width and the length, or we can simply dimension it. Let's click OK. Now let's look at the second type of slot, the center point straight slot. It's similar to the previous type of slot. I'm going to specify the width. Now let's create a center point arc slot. Lastly, we'll create a 3-point arc slot. Maybe something like this. Let's click OK and exit the sketch. And this concludes our tutorial about slot entities. Welcome to our tutorial on stretching sketch geometry. In 2D Sketch, you can now stretch multiple sketch entities as a single group, instead of having to modify each individual one. It's an enhancement that can save you a lot of time. Let's start by creating a single sketch. Now right-click and select. Let's go to Customize, Commands, scroll down to Sketch. Let's bring in the Stretch Sketch Entities tool. Click OK. Now we'll select some lines. Remember, when you select from left to right, only the entities fully within the selection area become selected. If you select from right to left, even the partially selected entities will become selected as well. Here we can enter a numeric value. As you see, it's a very handy time-saving tool. Our second option, parameters. Here we've got from to. We need to specify a base point here. And we can stretch as we need. When you're satisfied, left mouse click to accept your changes. This concludes our tutorial about stretching sketch geometry.